Hi, my name is Muhammad Shafiq Amir bin Samsul. I'm from Group D. I will explain about the introduction of electric potential. Okay, first thing, what is electric potential? Electric potential is amount of work energy needed to move a unit of electric charge from a reference point to the specific point in an electric field. Electric field is created by a charge. For example, let's say we have a charge here in the center. The charge will create an electric field around it. Inside the electric field, there is potential. Potential is the ability to do work. If the potential is high, it can do more work, and if the potential is low, it can do less work. The electric potential at a point in an electric field is work done to bring a unit positive charge from infinity to the point. The word infinity doesn't mean it very far. It means outside the field. It can just be a few meters away. As long as it's outside the field, it's called infinity. For example, this is the charge particle at infinity point outside the electric field. The charge particle will moving into the electric field and go to the somewhere point. Let's say point X. The charge particle at point X, we call it as the electric potential. And then the moving part or the line part of the charge particle, we call it as electric potential energy. So the formula that we can derive is dV, which is the differential electric potential or differential voltage, equal to dW, differential electric potential energy or work done, over Q, which is charge, equal to negative E. E is the electric field. Since the work done is measured in joule and charge in coulomb, the unit of the electric potential is joule per coulomb or volt, and the electric field is expressed in volt per meter.
Hi, I'm Haikal, and today I'm going to continue with potential difference due to point charge distribution and continuous charge distribution.
Okay, now I will continue with potential difference due to point charge and continuous charge distribution. Okay, basically this is the basic formula for potential difference. Is V equal to Q K over R. It is Q is the charge, R is the distance, and K is 1 over 4 pi epsilon. But if we have a point charge here, let's say we have A with charge QA at certain coordinate, we can find the potential difference from A to point B. From this formula, we can derive it to this formula. Look, this formula is basically the same as this formula, which is Q, and K we change it to 1 over 4 pi epsilon. And for R, since we need to find the potential difference from A to B, so we need to change it to 1 over magnitude RB from the coordinate B, minus by 1 over magnitude RA, which is from coordinate A. Next, if we have a continuous charge, like in a line or a surface or a volume, we need to change the formula. What we need to change is the Q. As we all know, dQ is equal to volume volume charge density dV, dq equal to rho dV, and for Q equal to integration of volume charge density dV. This is for case volume. It's also same for surface and for case line. And so we need to substitute this Q into the basic formula. So we will get potential difference equal to 1 over 4 pi epsilon naught integration of volume line density across the line dl over r. Same goes to surface and volume. We just need to change the charge and put it into the formula back. Then we need to do the integration to get the potential difference.
Okay, Assalamualaikum madam. Okay, my name is Syed Abrar bin Syed Ahmad Zawawi, and as you know me as Syed. So I'm from Perlis. So before UTM, I'm from KMKK, Kejuruteraan Kedah, Matrik Kejuruteraan Kedah. Okay, that's all. And I'm 21. Okay, now we see the relationship between E and V. So VAB is equal to negative VAB. VBA is equal to negative VAB. So the equation of plus is equal to close integration E dot dl equal to 0. So we got this. And then the close integration of E dot dl equal to gradient dot ds equal to 0. So V is equal to negative integration of E dot dl. So we got this from the gradient. And then we can see that the addition will be like this. This is the solution. E equal to negative summation of V. Okay, Assalamualaikum. For this part, I will solve one question by step. So the first step, we read the question. A square in the xy plane. This is square on the xy plane with free space of positive q. This is the positive q, and then this is the negative q point. And then a question: find the electric potential at any point P along the x-axis. So first step, I want to calculate the magnitude first. So magnitude, as we know, P point minus with the Q point. And we got here, this is the R1. We got here x minus with half 2 squared minus with half a squared third. So we do for all the part R1, R2 and R3, and we can solve it as R1 equal to R2, R3 equal to R4. And then this is the equation to find electric potential. So we insert the value in the equation. So we insert it, the Q point, positive Q and negative Q, R1, R2 and R3, R4. R1, this is magnitude. Okay, we can simplify it as we know that R1 equal to R2, and then we got this equation. Same goes with R3 and R4. So we simplify as factorize Q 2 pi epsilon and R1 minus with R3. So we insert the magnitude in the R1 and R3, and we got, this is the final. So question B, evaluate V at x equal to x equal to half a. So x equal to half a, we insert it in the x value. This is the x value here. we know that it can be cancelled out. Plus plus. So this is the simplified answer. Okay, that's all from me.